class and welcome to the first and introductory lecture on sustainable energy technology, which is a new NPTEL course on NPTEL. So before beginning this course, let me introduce myself. I am Dr. Shayok Banerjee. I am a professor in the Mechanical and Aerospace Engineering department at IIT Hyderabad. I am also associated with the Climate Change department at IIT Hyderabad and the new Sustainability School that is being set up at IIT Hyderabad to look at various aspects of sustainable energy transition. This course is titled Sustainable Energy Technology, and before beginning and looking into the details of the course, let me go through the major objectives of the course and who will be most benefited from taking this course. So this slide shows the course details. The major objective of the course is to provide a broad overview of the technologies related to sustainable energy generation and utilization, as well as their relative function within the energy ecosystem. Now, all of you may be aware to greater or lesser extent that throughout the world and certainly in India, there has been a big push for a sustainable energy transition. That is a transition of energy production and utilization from non-sustainable sources like fossil fuels, like coal, like oil, like natural gas, to more renewable and sustainable modes of energy generation, including solar energy, wind energy, hydroelectric energy, and even nuclear energy. This push has also moved into sustainable ways of energy utilization. For example, shifting from petroleum-based car engines to battery-based or fuel cell-based car engines. A recent push for moving from using non-sustainable wood-based cooking methods that was common in the rural India to using LPG for cleaner energy systems. And this course is primarily intended to give all of you a broad overview of these various new types of sustainable energy technologies that are coming up in the market, their individual roles within the broad energy ecosystem, their prospects and potentials, and how they will help all countries in the world and specifically India in driving towards a more sustainable way of energy production and utilization. On the right, you can see a snapshot of this year's union budget that was presented just 3 or 4 days ago. Okay, so let me just put my laser pointer here. So in the 2023-24 budget, the central government allotted for a big budgetary allocation for green growth and sustainable energy-based energy production. So over 35,000 crore of primary capital has been invested towards energy transition and net zero objectives. So here by net zero we mean net zero CO2 emissions, which is a key global target to be achieved by many countries by 2050 or 2060 at the latest to prevent global warming caused by CO2 and other greenhouse gas emissions. And we will look into those aspects in detail in the later sections of the class. There has also been a push to develop battery energy storage systems. We will go over those in the later half of the course and how they help in the energy transition, as well as improving the grid integration and clean hydrogen generation from renewable energy resources, for which another around 20,000 crores has been allocated for this year. So clearly, this is an extremely important aspect of our future growth as envisaged by many institutions as well as the central government. And we will see why that is and how the current set of technologies can help in driving that transition. Now, the next question that comes to mind is, who is this course for? Okay. So the course can be taken as an elective both by first year PG, that is master students in engineering and science fields, as well as third and fourth year undergraduate students in any engineering or science fields. Okay. Particularly, if you are planning to take the GATE on environmental science and engineering, that is the ES paper, then this course will be relevant to you because they have a section on renewable energy and sustainable energy aspects. Even if you are not enrolled in a core, in a curriculum, UG or a PG curriculum, if you are a working professional who is interested to gain a broad understanding of this field, this growing field of energy technology, then this course will give you the crucial technological background that will help navigate yourselves on any specific field that you wish to. Okay. So this course will cover all aspects of technology associated with this area, and will give you a good orientation of where we are at and where we need to go. Note that this course is more technology focused and is not policy or economy focused. Okay, so we will have some discussion on what is the growth trends, growth potentials, policy issues, etc. But we will focus more on the technological aspects because we are looking more at the engineering, how to engineer a sustainable growth than how to invest in it. So that aspect needs to be kept in mind. As prerequisites, the basic courses in engineering and science taught up to second year in any of the UG STEM disciplines, such as engineering, science, math disciplines, should be sufficient. We will usually use some of those concepts. I will go over them, but you do not need any advanced specific subject domain knowledge to take this course. So I have been giving this course at IIT Hyderabad for the last 3 years in the offline mode, primarily to UG and PG students of mechanical and aerospace engineering, as well as to the PG students of the climate change department, of which I am a part. But students from all other disciplines are also take it as a free elective, and they did not have a significant problem in keeping up with this course structure. So I hope you would not have a problem either. So that's the details of this course and who should be taking this course. We will go quickly over the course content as well. This is kind of the overall themes that I will hold on and go over in a chronological fashion. There may be some changes and modifications as we go, depending on any innovations or any requirements particularly. But this will be the broad overview. So we will do an introduction to energy in society. What is energy's current role in society? What is energy, after all, from an engineering perspective? How society is extremely dependent on the kind of energy technologies we use today, which kind of naturally shades off into the sustainability issues associated with traditional energy sources. What are its problems? Why do we want to make a transition at all? Because after all, over the last 200 years, our traditional energy sources have fueled this industrial globalized world in which we are living. So why make a shift? So that question will be addressed in the second set of our course content. Then we will go to renewable energy sources. This includes solar energy, wind energy, geothermal energy, hydroelectric energy, etc. So the various types of renewable energy sources that are like the key parts of this energy transition. We will go over briefly their technologies, giving an overview of their technology and their roles and their future prospects. Then we will go into carbon neutral fuels. These are primarily like biomass based fuels or hydrogen produced from green energy. we will look into these kinds of fuels, the biofuels, and what role they can play in the sustainable energy transition. So these two, renewable energy sources and carbon neutral fuels, are basically sources of energy generation. Okay, so here we are looking at technologies that help us to generate energy sustainably. Correct. Next, we look at energy storage and energy transmission. So energy storage and the grid. We will focus a lot on the storage and a little bit on the grid. Also, what are the changes that the grid needs to go through in order to integrate effectively with renewable energy sources. Why we need to focus on energy storage, why it wasn't that much of a problem before, now we need to focus a lot on energy storage aspects of the grid as well, why that is the case. Some of the major energy storage technologies, batteries, then there is pumped hydro, etc. What are their advantages and disadvantages? Then we will look into emission reduction and energy efficiency. As we will see, it will take a significant amount of time, several decades, to phase out traditional sources of energy. So are there ways in the meantime to reduce their emissions, to reduce their CO2 footprint and other pollution related footprints, and also at the end use sector, how we can increase the efficiency of the various energy utilizing systems so that the same utilization can be had with lesser amount of energy being consumed, because that will also help us in decreasing the harmful aspects of energy generation. Then we will go also into life cycle analysis, which is a part of this energy reduction and energy efficiency aspects, and will help us to understand and quantify the sustainability issues associated with various energy sources. Finally, review and conclusion. We will take a total stock of what we have learned and review it and end with a conclusion. Recommended books. You do not need to buy this book, but most of the content I will share directly through both PowerPoints as well as like electronic board work. So you do not actually need to buy this book. But if you wish to buy this book, I will follow many of the aspects from this book only, also other types of books. This book is Energy, the Environment and Sustainability by Michelites. It was released by CRC Press in 2018. So this would be kind of the recommended textbook for this course, okay, though optional. All right. This is the course structure that we are looking at, following the standard NPTEL format. We will have 3 hours of video lectures per week. We will also have, and the total course duration is 12 weeks. So this is a full 3 credit, 3 hours per week, 12-week course duration. We will have weekly assignments in multiple choice questions. Tutorial discussions and case studies will be uploaded on a weekly basis, as we wish to put them on weekly basis. There will be an MCQ type final exams and monthly live sessions, interaction sessions with you and with me as well. So where you can ask your questions live to me will also be hosted once per month. Okay. So this is the tentative structure. We will see if any modifications need to be made as the course goes along. So today we will have a brief discussion on energy and its forms. Okay. So we are looking at sustainable energy technology, correct? So what is energy? Okay, it's a very deep topic in some sense, because it's a question that cuts, which is basically being given by physicists, energy with many types of forms. But here we will more look at the energy from an engineering point of view, how we are trying to generate energy and utilize energy. So from that point of view, we will ask what energy is, what are the various types of energy, because energy, one of the key aspects of energy, fundamental aspect of energy is that it can be transformed from one type of energy to another type of energy, which apparently looks very different, but still both are types of energy only. And what are the various ways to measure energy? This is kind of becomes important in energy technology literature, because if you are going to read various energy related publications or technical notes when we discuss energy transition technologies, you will see many types of units that are being used. Okay. And it is quite easy to get confused of what unit is being used where and how it is related to another unit used by another group or another publication. So ways to measure energy and their interrelationships is also a very important aspect to understand and analyze the basic trends in energy technology as we go along. Alright. So what is energy? A very basic definition is energy is a conserved property of physical systems that they have by virtue of their motion in space. This is called the kinetic energy or configuration within a force field, which we call potential energy. So let's break down this sentence part-wise. Firstly, energy is a conserved property. That is, energy cannot be created or destroyed. As a physical system, all physical systems have energy as one of their properties. That's number one. Second, this energy property is conserved for a physical system. That is, it does not change in its total quantity regardless of what happens to the system. If you consider all transformations that are happening between the physical system and the surroundings with which it is interacting. Okay. Now, what is this a property of? Okay, because physical systems have many properties, correct? What is this a property of? Two things. It is a property that physical systems have by virtue of their motion through space, and this is called the kinetic part of energy, or by virtue of its configuration within a force field, which is called the potential component of energy. So two fundamental types of energy exist in the world: kinetic energy, which is a energy property that the physical system has because of its motion through space, and potential energy, which is a property that the physical systems have because of their configuration within a force field. Here the force field may be the gravitational force field, in which case it's the gravitational potential, or it may be an electromagnetic force field when it becomes an electrical potential, for example. Okay. There are other types of force fields also available. For example, within the nucleus of an atom, we have the strong nuclear force. And the configuration of the nucleons, that is the protons and neutrons, within this force field generated by the strong nuclear force is the nuclear potential energy, which is being harnessed by the nuclear power plants. Okay. So several types of force fields exist. There are four fundamental forces after all. So there will be four fundamental force fields and four fundamental types of potential energy. Then energy has many forms. So after these two fundamental classifications, energy can be sensed through many forms. Okay. So one is what we call thermal energy, which is the heat energy. Okay. You are obviously aware of what heat energy or thermal energy is in many of your physics and engineering classes. Similarly, we have light energy or electromagnetic radiation energy, right? Then we have electrical, and so we will go through all of these energy types and their basic structure. So I'm just giving you the names of the forms right now. We have the electrical energy, we have mechanical work, we have chemical energy, we have nuclear energy, etc. Correct? So energy will have many different forms. When we see a physical system, we interact with it, we sense its energy in various different types of forms, be it heat energy, electromagnetic energy, mechanical work, chemical energy, nuclear energy, etc. And what is the engineering aspect of energy? So some of the most useful things we need, like work, electricity, transportation, light, heat, all involve the transformation of energy from one form to another. So when you are switching on your electric bulb to get light at night, your electrical energy is passing through your bulb. It may be a fluorescent bulb or an LED bulb, and that electrical energy is converted into radiation energy or light energy. And this transformation is giving you the light that you need to do work at night. So the useful technology, generation of light at will, even when natural lights are absent, is happening because one type of energy, electrical energy, is getting transformed into light energy, which you are using for your day-to-day work. Similarly, we can talk about heat energy. Again, if you have an electrical heater to heat your water, to have a bath, there the electrical energy is being shifted to the thermal energy of water through the water heating technologies, and that is helping you to get hot water that you need for your day-to-day applications. So this comes then down to our understanding of what energy technology is. Energy technology is any technology that enables us to harvest natural sources of energy that are present throughout the natural world and to convert them to forms that we can use in our day-to-day lives. So a technology that enables us to harvest natural sources of energy in order to convert them to forms that we can use. That is what energy technology does. Okay. And so on one hand, we can convert, say, chemical energy in fossil fuels to thermal energy through our power plants. That thermal energy can be converted to electrical energy through our generators. That electrical energy can be transmitted to our homes through the electrical grid. That electrical energy then gets transferred back to light energy through our fluorescent bulb. All of these, the power plant, the electrical generator, the electrical grid, and the fluorescent light bulbs are types of energy technology that are transferring a natural form of energy available, fossil fuel, chemical energy of fossil fuels, into the light energy in to light up your homes. Now that we have an understanding of what energy is, we can discuss how do we measure energy. So here, two very important and related concepts come up. One is energy and the second is power. So we just discussed what energy is, and its standard unit of energy, the SI unit of energy, is joules, okay, which is kg into meter square per second square. Okay. The standard definition of joules is it's the work, which is a type of energy that is produced when 1 Newton of force is applied over a distance of 1 meter. So joules is basically 1 Newton meter, which when you convert into mass, length and time units becomes kg meter square per second square. Now power is the rate of energy transfer through time. So energy is the rate at which energy is being produced or consumed or transported with time is power, and its unit is watts. Typically it's joules per second, so it's kg meter square per second cube. So of course many of this energy technology requires energy transfer rates, so often watts become a very important unit in which power is being measured in these energy technology systems.